so let me start on a recap of where we were. So last week we got the paddles moving on the left and right hand side of the map. Right, so if I use the arrow keys, it moves this one. If I use the A and S, it moves this one. So we have that.
Yeah.
Sorry?
I can't see your screen.
Oh, sorry. Thank you. That's the one thing I need to do. Okay, there. Let me set that over for you. So yeah, so if you remember from last week, we now have the Pong paddles moving around on the screen. The left or the right side is up and down on the keyboard, and the left side is W and S on the keyboard. So we have functionality for like bouncing a ball off of these paddles, or well, no, sorry, bouncing a ball off of another ball. However, we don't have that for this paddle, so let's bring back the ball, and then we'll basically just shoot it sideways at this paddle so that we can test some collision detection. So if I go into our main script here, so last time we created this player type and we started to abstract out the concept of responding input to just the player, and then anything which is an actor is renderable. What we'll need to do now is bring back the ball, and so we'll need okay, interesting. I see. Okay. So first thing we're gonna do, we have our ball still here. We just okay, so we are now passing it in. If we remember from last time, we changed it to now go in as an array of actors. So our game state now has a player 1, a player 2, and then an array of actors for anything else that's on the screen. In this case, it's just our ball. So if we look at where initial game state is used now, we use it to initialize the scene. Okay. And so build scene must not be actually doing anything with, yeah, okay. So you can see here, we've actually just ignored that array of of variables right now. So what we're gonna wanna do is, because this array is of type actor, basically anything inside of that we should be able to render because of our existential type, which we've defined here. So we're saying that any actor will have the A inside, and that A will be renderable. So if we come down to build scene, then really it comes down to, like, I'll just kind of like pseudo this out, but like we have some, this is an array of actors, so we need to like we need to map over it, and then we need to map something over actors, and this something is going to be pattern match. So it's going to be I'm just going to use a anonymous function here to pattern match on the actor and lift out the A value. And then I'm going to create renderable render A. I think, let me see. I think that would probably be what I need there. Let's say we've got player renderables. And then we would just merge these together. So now if I run my code, barring there's no issue, okay, well that's a typo. And we probably have another issue here somewhere, yeah. This isn't necessarily correct. Okay. So let's look into mapm, just because I want to be clear on why that worked. So if we look at mapm, and then we look at fmap,
I think that when you were using fmap, you were using arrow notation to value out of the monad, so also some valuable content.
Yes, you're right. See, because this maintains the m. So we have our like this t a. You can notice here that we have our function a to b, f a f b. So the function that we're calling on a will be wrapped on b, and then we were using the arrow notation to effectively ignore that f context, and so we were just getting back b, but it was saying we needed fb. In this case here, the monad wrapper is actually separate from the function, or from the from the type that actually wraps that value. So here, type, this is array, and this is actor. And the m in this situation is that context t. So we are running inside of that context t monad, and we were effectively treating that context t as a functor, because a monad does also, like, you can treat it as a functor. I believe. I think they're very interchangeable.
A monad's a functor. But
Exactly. Functor is not a monad, but a monad is a functor. And so because of that, we were basically just able to use fmap to throw it away, but that didn't that made the resultant type not the correct type. So I'll just feel like this is actually a decent example. So like here, you have to remember, so we are inside of the context of the GLFW context monad. And this is just a type alias that I created, but this is the monad that we're within. And so if I'm doing this here, I'm never actually like forgetting about this. This would work if I went like something like this, but then I would need a way to actually, I'm curious about this. Give me a second. Right. And that's happening on is that happening on 162? Yeah, yeah. So now the problem here now is that player renderables and actor renderables aren't the same type. Now, thinking this through, I don't actually need the or well, no, I think a second. You'll see in a second if this will work. Because we could think, okay, well, what if I do this? And now it just creates the same problem twice. So the problem is that this create renderable function require, if we look at this, this is a type class. So this create renderable function requires a GLFW context. And so we are inside of a GLFW context here, but we're effectively, by doing this, we're just ignoring it. So create renderable, there's no guarantee here that create renderable can actually work. Like, we know that, like, oh, this would work, but the compiler doesn't know that this would work. So what we do instead is we use mapm. And that's one that you'll kind of just, as you're playing with it, get to learn to understand. But yeah, that's the reason there. So now we have the two paddles and the ball. The ball isn't moving yet, but that's because we got rid of the code to make the ball move. So let's get that working again. Okay. So how do we deal with updating the scene now? Updated game state. Okay. So this is where I need to now call a function to move the ball based on the previous inputs. But right here, I just have an actor, so move actors, and then actors out of the game state, because this function we're going to need to pattern match on the type of actor. So if I go move actor, is an actor a, how did I do? I'm just going to do V2. I think that's what it was. And then actor. And then we'll say move actor ball. Ball the only time actor. Just looking at the type of actor here. Where do I say ball as an actor? Right here, yeah, game ball. Actor ball. Okay, and that just means that ball needs to now have an implementation of renderable. Okay. The great thing about pattern matching is if I am forgetting a pattern, it'll tell me. So I'm just going to say, okay, so we've got actor, ball, B, and then we've got our movement. I had code for this previously. This is where we had that, yeah. Yeah. Okay. So basically, we just gotta get this code back here. So I'm gonna say let collision. Okay. So I'm just retyping it because some of it's gonna change. So we got has collided. I had that up here. Yeah, okay, so this function currently just working for two balls. Okay. So this function here, it's easy to kind of just like, I could probably just hack this because really they're only gonna be able to collide with one paddle at a time. So for all intents and purposes, like for this, I could just say ball paddle. Cool. Or I would go ball array of paddle, maybe paddle, to return which paddle it collided with. That's probably fine. Okay, and then so basically what I'm just saying here is that if there's if the array of if the array of paddles is empty, then there's no collision. And here I'm just gonna say and then we need the go with paddle. This is what paddle pause, paddle it. So it's V2 float for the position. Okay, cool. So here I'm just pattern matching over the array here, right, with the cons operator, and I'm just explicitly like defining the variables here. So now it's pretty similar actually, except now we're using width and height, so it's gonna be, think this through. So the distance on the x axis, okay, so we're still getting x, so it's really just get x v pause minus the position, but then I think we have to add so if we get the x, so this we get b pause. Ooh, this might be challenging now then actually. And I'll get into that why, because so we now have paddles on both sides. But I'm treating this as like, actually no, sorry, this will tell if this algorithm should tell if the things are overlapped in any way, so should work for both sides of the thing. Let me see. So it's get x p pause. This is the top. So this is the top left corner of the this would be the left. Where's the distance? Where's the size? Oh, okay, okay, I understand. So this is just getting the positions, and then I subtract out the size later. So just for trying to remember exactly how to write that. Okay. No, let's just test to make sure that it works. I'm not gonna go with it. Okay, so now it's if distance between these two things is greater than the size, so that would be the radius. Now this is the trick. I'm not sure.
So I've got an idea.
Yep.
So we're colliding with a square paddle. Paddle positioning in terms of the y value always going to be, is that going to be centered in the paddle?
No, so we have to add that. Another thing to consider is that in Pong, I don't know if you've noticed this, but there's actually there is a curve on the paddle, and that's something we're gonna have to. It's a digital curve. They don't actually show it.
Right, because it affects.
Because it does affect how the ball, right? Like if you hit it on the edge of the paddle, it goes on more of an angle, right? Does it not? Actually, I need to play Pong because that's how Brick Breaker
It
worked.
does.
But
But one of the things that I was thinking is
yeah,
that you might want, instead of a just get wide position, you might want to take the ball position and min max is the wrong word, but basically if the y values of the ball, like if the y value of the ball in
yeah,
the length of the match those y values and then offset bounce angle, but it's going to be directly face to face. I don't know if I'm doing a good job of explaining this.
yeah. No, I understand that. Yeah, it's getting that length. So I believe that's I need to do that in the distance calculation, like or like down here, because like the question becomes like on the y-axis, like do you check distance from like because right now this is distance from the top, like
So what we need is distance.
we need origin.
The line, right?
Yeah, well, because the way that the circles worked, it was just like give me the distance to the origin, and if those two are close to each other, then we're good. But the problem is, I think that was written with the assumption that it's gonna be two circles, because this is really just like this is literally previously. This is just checking the two radiuses. It's adding the radius because size divided by 2. This is the radius. So it's literally just checking if the distance between the squares of these two differences is greater than than these two radiuses added together, then it's collided.
Yes.
So that this is not going to work for really anything other than circles.
Well, I think it might if you basically look at the paddle as a collection of balls. Like if you basically make the paddle into at whatever point other balls are going, so that they always collide um, if possible.
Mm.
So I don't think I have a diagram that I can represent this with, but the mental image I have is that you have the paddle. It's like a static rectangle. Oh, nice. Okay. We're playing some kind of game. So I'm going to describe it. Let's see if we can. So we got the rectangle. And have a ball somewhere. So if you draw a line, figurative line, horizontally to the paddle, not
Well, the ball could go like that though.
what?
The ball could go
No.
like this.
So this is at the point of contact.
Okay, at the
So
point of contact. Okay, so let's just say these are like about to collide. Like next
Yes.
frame will be collide.
So you draw a ball at horizontal, then it's going to be sliding.
Okay.
Whereas if it's paddle, or maybe even further up, like if it's just nicking the edge of it, the ball that you're going to on the paddle, it's so it's down sideways.
Oh, I see what you're saying. Because if you bounce it here, then it's still gonna go this way.
Yeah, and I mean, you could, if you wanted some nuance, you could.
It's like I thought it was like this.
No.
No,
I mean,
not for Pong. That's Brick Breaker.
I think this way is a much more. It's gonna cause a lot less mental chaos, and we can figure out how to do some. Get this. Figure if you just draw a ball or a ball-like thing for it to collide off of at the point,
Yeah. I mean, this is a good technique. It's still just it's using circle colliders, right? Which is
Yeah.
okay. Circle colliders are the most. So this is one thing I'll make as a point. Circle colliders are the most efficient colliders. So there are actually a lot of cases where people will put a bunch of circle colliders together. So like this isn't that far fetched, I guess is what I'm kind of getting at. It is an efficient solution if it works. So yeah, I guess then really it's just about I'm just trying to think of like how do you actually because then this basically the way that this becomes is that oh okay actually yeah so then this calculation just remains the same and what we would need to do then oh but then how do we so the trick is like knowing where the ball hits relative to the paddle or not even it's
Yeah.
like
So you draw. Basically, you need to set the. You don't just get the Y position.
oh the y is the same yeah the y is offset by the ball's y or the well the y equals the ball's y max paddle height yeah I get what you're saying about max
The min max.
the min max yeah I get it yeah okay let's try that that's good okay so if we go um so the balls are still fine so really it's is it the distance that okay so and I'm forgetting whether the problem is I'm forgetting whether the paddle was bottom right or bottom left. Let me see if I can figure that out by the initial game state. I probably can. Start one pause. It's -1 on the x. Puts it that way. Okay, yeah, I believe it's yes. Okay, because it's 0 and it's right along the edge, so it is bottom left. So everything's oriented based on the bottom left of the paddle. So then I'll need to. So in order to get the distance, like for the y, if I'm so first I just want to change this based on the origin. Like let's do the distances should be based on the same like similar origins, right? So like get x p pause plus p width divided 2 and then we'll do the same thing here get y minus or no it would be plus it's just I'm used to the other way around plus p height divided by 2 so now these distances are based on the origins but I don't even know if okay I see so we need to change no, this is where this needs to change so x is fine all of this is going to happen on the y so it would be because this distance is what's used in the actual collision detection
between the ball's y value and the paddle is within the width of the paddle, then they can be equal. But if not, then it's just like whatever max value is. You offset the paddle button. If they're aligned horizontally, then the paddle's y position and the y position are equal. If the ball is beyond the edge of the paddle, then the paddle's y position whatever the bound.
Yeah.
Like
I understand that. I'm just trying to figure out.
those words right.
Yeah, like I'm trying to. The problem is I'm trying to change this to do that. I could probably just try to rewrite it even, but like I think it's just in this distance, like in where this distance is. I think we need to do like a min max, or like basically a clamp. Like we need to go. Okay, so we need to go. Okay, we've got the ball pause of y. We've got the ball pause y. Right, we got this y. This is like 1, 2, 3, 4. 1, 2, 3, 4. So we've got here. Let's model out this scenario. We've got a ball of 2. So ball 2, 3. Paddle. Let's just think based on origins. So this would be at like 2, or it'd be like 0.25 for x, and then 2 for y, let's say. So here we know that the paddle. Sorry, what's up?
Origin is based in the middle of the paddle or the edge?
I am offsetting it to be the origin just for this example.
Okay, cool.
And then we can, if we notice that like we're basically just offsetting and then removing it, then like that's just an identity, so we'll just remove it. But at least this will help me think about like, okay, we've got position of 0.252, and so really the 2 and 3 are what we're paying attention to here. The 2 in this case, we're saying that okay, as long as the ball, so we know the height. Okay, we've got height is equal to 2. So we say the paddle plus or minus the height divided by 2. This is our clamp, effectively. So then what we need to say is, because the way that this works is kind of weird. This is what I think. It's like has collided and then apply collision. That's fine, but I'm wondering if like we just. No, actually, this is fine. Because we need to just detect when this happens, right? So is there a collision? Not necessarily what's the angle, but right now, in order to know that, like I'm trying to understand whether we like physically create a ball. Like I guess we could like just physically create like a temporary ball at this position, right? So then it would be new ball would be the ball's position. Okay, so this is what we need to do. We just need to at all times create a new ball, always, and then we're just checking if those two balls collide. So
if you want to optimize, you can only create the ball if you're in like a certain collision range.
Yeah, that's common practice. But I mean, we're making Pong. But I like your thinking. we do that when we get into, if we do like more complex physics simulations. Like I'd like to like get to the point of like
10,000 ball 3D.
literally like 10,000 3D balls, throw them in a box and see what happens, right? That kind of stuff's fun, and I'd always want to try it in Haskell because Haskell's really efficient for that kind of thing. So it'd be kind of cool to see what it can do. Okay. So we're gonna basically, all this is new ball where the x is equal to px, and the radius, or the diameter would be equal to the p width, and then the is this the y position is, this is where the clamp comes in. Clamp of the of the plus or minus. You get that, this thing here. And then it's the clamp of that and the ball pause y. Okay, so that should work. And then that ball is what we use to do a distance collect. Now we do a distance collection on these two. So basically we've got our x. Here is where we need to like basically effectively like create new ball. And then get distance between the new ball, or the paddle ball, and the player ball. And then we replace that. And then the rest should just work like normal. Put that up here, because this is the one we're rewriting. Okay, so don't even necessarily need to create a new ball. We just need the trick, though, is that you can see here the apply collision. We'll rewrite the apply collision. I don't want it. It's kind of weird if it takes a ball. Like we're doing this more conceptually than like actually creating like a ball object. Because really there should be a circle collider, which is separate from a ball, but that's fine. Okay. Okay, it's gonna happen. Needs to happen before all of this shit. Okay, so really what I'm saying is we need our that's a bit more accurate. So circle collider X is going to be the, I think we just said is the paddle ball, the paddle X. That'd be the origin. And say circle collider Y. Okay, so then circle collider Y is the clamp. Is there a clamp function? I've never actually. Yeah, Yes, there is. It comes from what? So we're just going to say clamp. And this would be, for the first value, would be p height. Wait, no. It's got to be p pod. I mean, if we're already bottom left, then it makes no sense to go to the middle to then come back down. So I'll just go clamp between p pause and p pause plus p width, p height. So clamp it between the position and height, so that would be between the actual paddle. Then this would be the B pause. Okay. And the circle collider diameter is just p width. Okay. 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 In theory, that should work. Any thoughts?
Are we allowed to have two Haskell added functions?
Oh, you know, I'm gonna remove this. Yeah. Which reminds me, yes, I have to add this now. Okay, there we go. Remove this. Now applying the collision.
Are we still returning a maybe paddle?
No, I'm trying to think. I'm leaving that part for now because I'm not actually sure how we want to do handle this part. Moving the ball, that's fine. Applying the collision. This is where we calculate the bounce velocity. Currently we use balls. To test this out, I could just create a ball like, so what I would have to do is like, so if has collided is true, then create, because ideally what would happen is that like this would pass back like the collider that it actually collided with. I'm not gonna like, we're just, that's too much for right now, because I want to get it working. So I guess like for now we can just be like, you know, if it has collided, because here I guess it really doesn't matter what paddle, so we'll keep this as true. And then what we'll do is if it has collided, we will just construct a ball with the paddle information.
Cool.
Because if yeah, it's kind of like it's kind of like the reason I don't love this solution is because we're doing the same calculation in two spots now, right? As opposed to passing this collider with this clamp information, we're gonna have to basically just calculate that again. But
that can be optimized later.
it can be exactly. That's an optimization, and that's actually the way I like to do things. It's called semantic compression. It's like literally write it twice before you go and change it, and you'd be surprised how many cases that actually saves you, where you think something's abstract and then you go to implement it and it's like, actually no, this is not abstract. Okay, so let's do that then. So then it should be pretty straightforward to just keep the code that we have already, and we just need to change the update function to check this, to create the new ball at the correct position, and then do that. So we've got our game loop here, taking our input, and then here's our updated game state. So yeah, so we have our move actors function, and that's where we'll do this. So collision occurred, we'll say has collided, player paddle, or sorry, no, it's any paddle, but it's going to be has collided. Ball and then paddles, okay. So we want to know if has collided, B with the, yeah, so I need the game statement. I gotta go like player one. I'm just gonna pass in the game state and do everything in there. I need the state of the okay, so I need to get, basically what I need is the player paddles. So I need to it's pretty straightforward. I basically need to map for. Oh wait, no, because the players are individual, so I need to create an array of game state player one. Is that how I did it? Yeah. Game state player one, game state, and this is basically like that, but an easier way to. Whatever, it's fine. Okay, so we get the paddles, and then I'm gonna check if we've collided with any player paddles. So then we're gonna say collided ball equals if collision occurred, then apply, and this is where it gets interesting. So this is where we need to create that other ball. Oh, I see. Wait, I don't need this anymore. I just need, well, wait, if collision occurred. Oh, I see. Then it's apply collision B, otherwise it's just B. Sorry, yeah. Okay. So now what goes here is the question. What's up?
Could you maybe find find a has collided over paddles, and then if it exists, apply the collision to that paddle?
Yes. Great. Because that would be in the same. Yeah, exactly. Because fine. So that's a great example of how like you can just recognize an existing structure and apply that to an exist. Because this, you're right. This is just, we have an array. We have some function that maps over the array with a condition, and if that condition is true, do this with that specific thing, and that's just fine. Right, so the find function takes a predicate and a structure and returns the leftmost element of the structure matching the predicate, or nothing if there's no such element. So this will find it, and it gives us the actual A, right? So then we can actually just map on that A, and then if it's nothing, do nothing, right? Okay, cool. So let's say, so great. So if we go find, I'm just gonna write this out. And then we have a function that takes an A, goes to a bool, which just means we go has collided B, because we have to, it has to be, like they can only have one argument, right? One argument of A. So we're gonna partially apply has collided to B, so that this gives us a function of like this has collided B to actor, or to bool. Sorry. So this is our. It takes in the array of actors. So A here will be array of actors. And so now it's expecting, since foldable, so foldable is T. In this case, the foldable that we're using is array, because array is a or list. List is a foldable type. And then we've got our A. And then here you can see, so now we just need to pass in a list, since we've said it's a list, of A. And that A is our paddle type. So this is correct. So now the next argument is simply just the player paddles. Okay, and so this is going to return us a maybe collided. Okay. So then, if with our maybe collided, I think we can use from maybe. I think I'm just trying to think of what there's a couple of ways we can like match on this. There is a from maybe function. From maybe function takes a default value and a maybe value. If the maybe is nothing, okay, so this will give us the paddle itself or nothing. Or no, so this actually isn't what we want, because this would be what we would want if we wanted to like, we wanted the same type of value in either case, right? Because you can see here, takes an A, maybe A, so this is, it's the same type. Like we can't do something differently for nothing and something differently for just here. So let's just like write this out manually first, and then if there's a pattern in it, we can find that. And Galen's back. Welcome back.
Hello.
So we're working on collision detection. Zenon had some really good ideas for how we could reuse the ball collision detection code that we had to work with a paddle. And so we're now dynamically creating a ball at the point of potential collision. And so we're using that ball to actually, because like if you collide here in the paddle, it still goes straight. But if you collide right at the edge, it's technically it's gonna send that off on an angle, right? Yeah. And so if we use a ball here, if we basically just clamp the math that we came up with was we just clamp the y value to the ball's y value, and then you take and then you clamp that to the paddle's position. Then that ball it'll always either be a perfectly like perpendicular collision, or it'll be clamped at the edge, in which case it'll bounce off the edge of the ball. So that was really a great solution there. We've got it pretty well implemented, and we're now using the find function to check if there's been any collisions against any player paddles, and then return that player paddle.
Cool. Yeah, I like that. Yeah, I guess I completely forgot about that with Paul, that like if it's at the edge, it will like bounce differently.
Yeah. Well, see, we all had different kind of understandings of it. Like I was thinking about brick breaker days where like for example, like if it was this way, first of all, that would actually might be a fun one to build, brick breaker. But it was like this, right? But like the mechanics behind it were actually like this. Right, like you had like this paddle like that, and so I was kind of thinking like that. I was like, okay, well, we have to create like this circle that's like the size of the the paddle, and then use that part. But no, yeah, traditional Pong specifically is just on the edges.
Also, if you do want more of that brick breaker experience, you can what the right like pull the paddle ball in towards the origin slightly, like it's a rubber band. So if you're around the edge, it's gonna
Yeah, there's lots. Yeah, lots that you can do. I honestly, the way I would probably do it is like you would you would take the so you've got the height of the paddle, right? What you could do is set that to be the diameter or the diameter of fuck, what is it? The diameter of the circle, and then just set the origin point to be the this point minus the width, and that way like the circle is literally like the circle would be like here, and it would be drawn like this. And so now
Okay,
like you actually have the collider, like it'd be actually like that, right?
yeah.
But I think that's how Brick Breaker does it. But I really like this. This is smart way of doing that. Cool. And also we had a quick little discussion on how circle colliders are the most convenient, like they're the most optimal. So at any time, if you can work that into your collision detection, it's gonna save you a lot of frames. Okay. So now we have our maybe collided. I'm just gonna. Oh, we can't do that here. Be just say in. So if there's no collider, or if there's no collision, then we are just going to return the actor. And if there is just a collision, then we're going to apply the collision. Between the ball, and this is now where we have to basically construct a new ball, right?
Right, with a new state and position, or position changes, right?
Yeah, sorry, no, but this what I mean is like we're creating a ball. Like this is something that we would change and fix. Right now, our only way of doing a circle collider is this ball type, but ball is also like an actor in the game. So I digress. We're just not going to add it. Like what I would typically do is I would have like a collider type, right? Like or like a circle collider, and we'd have some way to create that and pass it in here. But that's fine because right like we don't actually have a ball on the paddle, right? Like from the sense of like a ball is something that can be rendered, it's got a label, it's got like, and we're probably going to add other, we might add other things in the future to the ball, but that's fine for now. For all intents and purposes, it doesn't really matter, other than just we should note that this is a design thing that we should change in the future. So if I go ball pause, so the pause then is, this is where it gets a little tricky, or I guess because we have the player paddle now, so we have our C. So we would need the ball's X position was just the paddle's X.
Fly collision just takes a ball.
Yeah.
Wouldn't it just be? Could you just pass the variable?
Pardon?
Or are you trying?
No, you shouldn't. At least not. Like.
Oh yeah.
I mean, we should, but that would still bring us to the same thing because we'd just be implementing the pattern for ball. Like you should in this case of like there's in the case that there's if there's other things that need to collide, then it'd be better to do it that way. But right now, the only thing that collides is a ball, so I'm just it's fine for now. But
I'm curious too. Like, did change the still like
Yeah.
Could you unpack? Like, this is one thing I was wondering. Like, I wonder if we us like I don't know if you can. Maybe we're gonna test it and punish on.
What, this here?
Yeah, like could you unpack actor?
I have no idea, so I'm gonna find out once I compile this. But that's not what we're focused on right now. Let's assume that we can, because that's not. I don't think you're understanding what the problem is. Just respectfully.
No, I know. I'm talking about something different.
Yeah. Okay. Cool. Yeah, we will get to that. We will get to that. Pardon?
Sorry. I feel like in the short term, what I would do is turn the just C into a do statement, and then take all the calculations we did.
That's what I'm. Yeah, I was trying to avoid it, to be honest. But yeah, like, because effectively what we need.
But I use that shit all.
I do too. But what I was trying to avoid is like we have to now. But yeah, there's really no way around it because we need to get. Where's the has collided? Like we need to do this calculation again, right? Like.
Yep.
It's probably the most complicated part of the whole thing we're doing, right? I mean, the collision detection.
Yeah, and I'm fine to have this be something that we refactor. Like this is effectively what we need to do, right? And then we need to create the ball. Like I'm just gonna kind of pseudo this in, and then we'll fix it. So ball, we need the position. The ball position is gonna be the circle collider X, circle collider Y, and then the what's the next thing on ball? Position, size, velocity. So then the size is just the width of the collider. That's another thing is this C is now an actor, and I don't think I can actually get the paddle pause to Galen's point. But let's just work through it one step at a time. Ball. So we're gonna say.
And to be clear, I you know what I will say, I was overstating the problem. Like
it is possible to do it. Like I know you can do like pattern matching to get the B. Like I know that you can like do this. I don't. It might be like actor. I think it's actor B, and then this will be like whatever it is. I don't know. There is a way to be like give me all the balls from because that's the whole point of the existential. Oh no, it's not actually. But fuck yeah, no, you might be right.
Well, I mean, one thing I was thinking about doing, like, how would I was thinking about this a lot over the week, is like, okay, as an enum, like you could do it, and I could think about how to do it. Existentials, you could still build a class that's like collidable with A and a B, both A and B collidable. I don't know what that would exactly look like.
Right. I'm just saying. So you're saying like existentials might not even be necessary here. Because I thought, don't you need existentials basically to like do the inverse of polymorphism, like where you?
It's kind of a sliding scale. Like I don't know where you would ever adjust them, but they are like a useful thing, I guess. Like so for like if we think about it like this, let's say you have one type which is ball, right? That's like kind of like the simplest non-polymorphic case.
Yeah.
And then we could have like an enum, different cases, all or a paddle or something else, or we could have an existential, which is just like we are not ever going. We're just going to call a method that we know it has.
Yes.
Is basically what it is. So
Yeah.
if we can write it in the last way, then we could do existential. Yeah.
So the thing that I've been working with a lot lately, I've been needing on like library, and I've just been giving random, or not random, I've been giving data types of to JSON and from JSON.
Yeah.
According to basically an arbitrary. As long as I can implement that method on the data type, then I can cast it a value or value. So I'm wondering, is that a viable solution when you want to collide something to have an instance of collidable, or does that not work?
Yeah, you should have instances of collidable for sure.
Yeah, I mean, classes are kind of like the most generic thing you can do, right? Because they really just say, as long as you've told me how to do it, sure. So like with to JSON, right? Like you can only call JSON on something that you have written somewhere JSON. So like yeah, if we can write a valid solution of or like collidable, then we are golden.
Yeah. So
I don't know how to do that.
So the problem, so that gets into like more of an entity component system structure. Like, yes, I would say that's the way we should do it, but in terms of just like getting Pong working,
We're so close.
yeah, it's like that would be a rewrite of a lot of this, and like that's fine, but I would rather do that for a new project, right?
Totally. I mean, honestly, like, that's pretty good. I'm curious if like because a lot of like the more advanced house, like, I'll be honest, hard to access. Like I'm curious if know like a way to write that editable.
Oh, I'm sure it would. It would re-architect this whole thing for me. I use Claude all the time, and it's great for this kind of thing. But like, yeah, I don't want to do that right now.
Yeah,
and I think
so
it makes
close to
like we're
finishing
literally
this
so
project.
close to finishing Pong and moving on to a new project that like that's a no. We're not doing that.
All right. Hey, fair enough.
Yeah.
Fair enough.
But I would say like for the next thing that if we do any kind of game or graphic stuff, absolutely. Like we're going right from the start. We're implementing an entity component system right from the start. First thing we do, because that's effectively what we're running into here. Is like you need a way to attach arbitrary functionality to arbitrary actors. Like that's how games work. Is that like you've got oftentimes you have to do that dynamically too, right? Where it's like, oh, this thing now has this effect on it, and like that's a component that you just attached to it, and it's like how do you define all of that in a type safe way without putting in some real work into creating interfaces and everything, and so that's it's typically called an entity component system because it is quite a like it takes a little bit to get that working, but then once you have that, it's like, okay, I want to create a component, and this is what the component does. This is how it impacts whatever the polymorphic type is beneath it. And then you generalize that structure so that yeah, you can have something that you're just okay. This thing is now collidable, and like you don't have to you do not have to, because I should basically what entity component system removes is the need now. Like, see how I have move ball, or I have has collided ball paddle. No. This should just be has collided collidables. Nothing like it should not care about anything about the ball or anything. This should be move.
Yeah.
Right.
Well,
This should be so, and that's where entity component systems come in.
Fair enough. I guess what I'm trying to say then, I think I better understand. Is like my thought process would be like how to fix this. Is like only thing that like really seem to care about here is not all actors.
Yeah.
Like we're writing this in terms of actors, whereas like
Yep, the easiest way to do this is just to say fuck you. Sorry, part of my language. Screw you to the actor. And to.
yeah, do that, yeah, but like, yeah, I mean, just I meant for the function, like.
No, but I'm literally saying, like, because this is what's making everything hard.
Totally.
Right.
I guess I'm saying.
For now, let's see if we can.
Recompilation.
Okay.
To avoid changing a bunch of code, I just wouldn't take. Just leave it.
Yeah, leave it. Yeah. We can kind of avoid it, ignore it here, is what you're saying?
No. Like you just remove the code actor. Right, and now you're gonna now GHT is gonna complain.
Oh, I got you. Yeah. Fuck, it's everywhere though.
No, just don't remove
the actor. I think we're just refactor move actor to move.
Yeah, like I'm not too worried. Yeah, exactly. Yeah, that's what it is. That's the quickest, dirtiest solution.
Undelete the definition of actor.
Did I? No, I did. It's still here.
Oh, okay, cool. Sorry.
Yeah. Now we gonna have a big problem. Oh wait, what the fuck? We already had a move ball. Okay, that'll have to be. This is no longer relevant. I will bring it here for reference. Okay.
Oh, what was the point of making this move all or factor?
Because this didn't do any of what we needed it to do. This was just moving the ball. Like this here will probably just get moved to the bottom of this.
It didn't do any collision detection too.
Yeah. It's a name. It's nomenclature at this point, but yeah. Okay, so apply collision B on this new ball, which is created with the collider and the. I'm just gonna go ahead and do this. Okay, so now we've got apply collision B ball clutter. So this is just collided paddle. Okay. Okay, now we're gonna see. So we got B pause. Apply collision B height, and 0. Okay. Apply collision gives us what, a new ball? Yes.
say you have the do, so do let, not a. You don't need that in.
Oh, you're right. You're right. Yeah, it's a do let. Yeah. Thank you. And then this goes.
No worries. But as a whole, you're in a. I don't know what the ones at the bottom are. Like your syntax is all weird.
Well, I know this isn't. This is just the way I write code. Sorry, I know to other people it might seem confusing because you're like trying to figure out why it makes sense, but it doesn't. Like this line is not in my memory at this. Like it's not in my.
Bro, why your syntax all weird?
Love it. Or do you even
It's actually, I'll be honest, it's because I have a really kind of poor short-term memory, so like I like to keep things on the screen while I write. It's weird.
Same.
Yeah.
I mean, when your brain's overloaded, I feel like anyone has short-term memory when your brain's like working hard to solve a problem. Like I don't think I have necessarily bad short-term memory. Like why can I not remember the name of the function I just used?
yeah, that's fair. Okay, so we've got our collision occur. Wait, no. So this no, yeah, we don't need that anymore. This was old code. That's why we're confused. So this here now in case, so that'll return. I mean, yeah, that I think is correct. Guess we'll find out.
Is apply collision monadic?
No.
And also, we can't use. I mean, I don't know if we want do text here. The
Oh yeah, no, we're just there's no reason to. Yeah.
Yeah, you could, I mean, and you could just say let in.
I can say let and then just in here, right?
Yeah.
Yeah.
And you don't want that equals on 245. You want the arrow.
Yeah. Cool. Okay.
A lot of complex pure functions here.
Which is good. That's what you want to do it. If anything, I need to get more used to writing like this because, like, you want ideally everything should be pure.
Yeah. I mean, and honestly too, like if you're comfortable with like do syntax, you can kind of use let the same way. Just like let step 1 equal step 2 equal 1 with.
Yep.
Yeah.
That's something that I haven't figured out yet. Because like I was saying, I just use do syntax, even when it might not be the right solution. I think let in syntax is maybe something I should practice a little bit.
Yeah, it's.
I mean,
yeah, go ahead, Galen.
Well, I was gonna say like one trick you could use to keep doing do syntax just for like what it's is like let's say run identity, and then identity like make monad. Like it's not really gives you like tags of sense. Like you're just wrapping it in identity itself, which does absolutely nothing. But yeah, like I try to get comfortable. It does feel weird to do let in. But like once you get used to it, you like it's just dense. That's what it is. It's dense. A lot of Haskell. It's just dense.
Yeah, like this. I mean, this is just defining the variables, and then so the way I look at it is like, if you're not inside of a monad, if you're inside of a pure function, then you're just like this in is where this is where your actual function starts. Like this here is like everything here is just like basically like your function header almost. Like it's like defining variable. It's not your function header in the sense of like this is your function header, right? But it's like the actual function that's going to get run is like your end resulting function is here. You can run functions along the way, but these are really just defining different labels. And you could, like for example, I could just also come in here and go circle collider y, right? Like if I wanted to do the full definition here and then just return that here, that's totally fine too. So it's kind of just like, this is like defining the functions that you're running, and this is like returning back. That's kind of the way I think about it.
Yeah.
And then it's just like, it's like, if anything, it's like more like normal programming this way. Whereas like do, if anything, like I'm more interested in the fact that you default to do, right? Because do is more would seem slightly more complex, but yeah.
It's funny though. I've noticed a lot of like we for a while, a long time ago, we contractors for Ace. When we were actually like Ace interview, and a lot of them, like when they were showing us their projects, would like just default to use everywhere, and they kind of admitted that like that now it's like not things. No. But yeah, I don't know. I think it's like a psychological thing. Anything. But even too, Kyle. I guess like us to kind of learn from Haskell from principles, and I feel like I wonder if that's something they actually did well. Like, I mean, maybe they could have done it in 2,000 less pages.
Yeah.
But like I feel like I kind of defaulted to let in syntax because he did a really good job of explaining like how Haskell is language, and just because you define something doesn't necessarily mean evaluate it. Like I mean, really, in every syntax in other languages is like very much monadic, right? Like a JavaScript statement is a monadic thing. Even like setting a variable is a monadic thing. That means like you're gonna actually do something. You're gonna perform some effect in memory. Whereas like saying let x equal 1 or let x equal this like massively complex mathematical equation does not mean that anything is gonna happen. It's just like a reference used later. Yeah, and you're really just thinking about it from the compiler is just thinking about it right from the end of like if it sees like a let in syntax, it's gonna evaluate the in part first. Evaluate, right? So if we have like let something in fxy, right? F being a function, x being one argument, y being the other argument. It's gonna like first read fxy, and then it's gonna say, well, now I need to know what the value of x is, and then it's gonna keep working backwards, right? Same for y. It's gonna keep backwards until it has a value or ultimately evaluated, right? Like a full mathematical function where we do some crazy stuff is ultimately going to end up being like 3, right? And when we call that function, it's going to result in a value of 3. We're going to have something that looks like f takes the arguments of y, where x and y ultimately evaluate to. So yeah, I don't know if that helps.
I haven't heard the term disjunctive normal form since second year, man. Blast from the past.
Oh really?
Yeah.
What's actually that? Because I said weak had normal form. What's disjunctive normal form?
So this is totally a tangent. We can let Kyle work, but basically pieces of logic.
Yeah, I'm trying to figure out this last little piece here.
I'll just look it up in my own time.
Yeah, do that.
Thank God.
Handle collision. So that's applying the collision to the ball. Applying collision changes the velocity. Okay, so, and I realized that we do still need this old move ball function because that actually deals with the movement. So I rename that to handle collision. In here we're gonna go Okay, so we've got our game state ball. We effectively want to, I'm gonna say move. I guess I could technically move ball and then do handle collision, or handle collision first. On the ball, and then I need the game state. That's what it was. That's what I'm missing. Okay. Wait a second. Sorry. I don't need, yeah, this is weird. I want the ball to be from the game state. So that's why I'm going to do that. Oh, what did I just do? Okay. I think we should just have this. And we say here. Is that the right? I know I can do that. It's weird, it wasn't letting me do the syntax that I'm used to, so I'm feeling like there's an error, but I know that I can do this. Okay, fine. Okay. Move ball, handle collision. I no longer care about doing this correctly. I'm going to, well, it's all going to be correct. It's just like, from a design perspective, like, it doesn't matter that much. I'm going to make that still return us a ball because I want this, I want to handle a collision, have this return me the ball, and then I want to move the ball based on the collision. That's fine. Then we will, that should actually handle all of that. Okay. I like when it's just simple. Now I've just made a small change here. I'm now with, I'm now just, rather than keeping track of the actors, I am just going to change that to ball because it's going to make things so much easier. But I'm not going to remove everything else that doesn't need to be. So if I go game state ball, change this to a ball, then I'm going to play compiler chess from here. Main 247. this point, I don't want to do all that. Okay, it's not gonna work either. Move ball. I will just do it like this. There. Match type float with actual. Oh, that's fine. I'll do. Change the move ball. Where else do I do? Okay, variable node and scope. B ball. Apply collision. B, no. V2 float with actual type. Yeah, so I need to do. Where's that? Yeah. A V2 float with actual type paddle. Backdid V2 float. Oh yeah. Variable node and scope. Find. Where is that coming from? Data.list. Not foldable. Data.list. Hmm. Yeah, that's gonna return an array. I thought find just return. Oh, it's gonna wait. No, it shouldn't.
Just to put it on your radar, Kyle.
Yeah.
Obviously, your decision. Um, Later reviews and its projects after this.
Oh.
Just
Well. Oh, okay. I didn't know that actually, but okay, that's fine. We're about like 5 minutes from having this compile. Is that?
yeah.
So with that in mind, do you want to help me with like just ripping through these compiler errors?
Yes.
So this one here, it's an actual type. So I was expecting that. Oh shoot.
To help me with ripping through these, did you do split screen?
Yeah, I was
between
just gonna think. I was actually just.
I
Gonna
don't have the I don't have the memory either.
Yeah. So yeah, so this one here. So it's expecting. So I'm passing in player paddles, which is an array of paddles.
Oh, it's expecting that Haskell item must return a list of paddles. Is that true?
No, has collided has to just take the A to bool.
Yeah, but you're no. Like, not like
Has collided
A,
function.
the A is a
Yes. Oh wait. Let me see.
check. We need to check. I would next check. What
A shouldn't be a list. Oh, wait. Has collided? Yes, it is. I think it's yeah. Okay, that's why. Yep. So this should be instead it should be just taking one paddle. Like this has collided because we're putting it over all the paddles here.
That makes sense. Sorry, but can you ask lighting?
No, I know it makes sense. Has collided. It needs to just take one paddle, not both, not the array of paddles.
What is it return?
Bool.
Oh.
Yeah.
Yeah. Oh, okay. Yeah.
Yeah.
That's why.
Yeah. So. Yeah. So this used to do like this used to be a recursive function, but now we're using find. So let's just do this, and then.
Sure, like too, like when sorry, I'm very particular with like cause, you know, like there's it's always the same. But then like as a result of what the compiler error tells you, oh, there's this decision to be kind of the vibe.
If distance is if in my old age distance is greater than, then it's okay. Oh shit. Okay. Actor renderables 60. Okay, just to make this quick. Actual type. Yeah, this is where you get into that issue where you can't get the ball back from the actor.
Yeah.
I'll just do that maybe. Okay, no 107. We're working our way up here.
And two, like to be clear, like everything we've done before, we can still just say like you know, wrap the thing with an actor and then render it.
Yeah, exactly. It's a way. It's the problem is where do we create that existential and forget the original type? Like you know what I mean? Like
yeah,
you would almost want to you would create the existential like at the like where it's relevant, right? As opposed to like creating it at the boundary and then passing it all the way through the application.
Right. And I think
that's the problem we're running into. Yeah.
It's easier to say where we don't want it, which is where we need to uncover like what the actor is. So if we need to know this is a ball or this is a paddle, then
yeah, for that specific case, and like that's where you think about your system in layers, like layers of context almost, right?
Yeah.
Where it's like within this context, okay, maybe we do have just the actor, but nothing beyond that context is going to care about anything other than the actor.
Exactly. Yeah. And 101 just changed that 101 added the second argument just turned into an underscore. You don't even care.
Oh, it's not an array anymore. Yeah, that's that one. And then this one here, pause. It should be P. It's I think P pause, but let me make sure. Okay, since why? Oh no, it would be.
I don't know.
Distance y is the ball plot. The ball pause. Yeah, that's. I think. let me make it. Let me give it a sideways velocity just so we can see if it if any of this code worked, and then we'll call it there for the day, regardless of whether it works or not. If it doesn't work, we'll figure out why next week. So where's the initial? Gotta catch it.
We'll never make it.
We'll never make it. No.
Oh.
There's probably something. We'll figure that out next week.
Yeah.
But yeah, we're very close.
That was so fun.
We'll never make it.
Yeah.
All right. Thanks everyone for joining. I'm gonna end the call here, and then we're gonna do a review of some projects.
Yeah. Oh, I'll send I'll to you guys.
Cool.
Or honestly, I mean, does it? Then we could keep things private or all or.
All right.